everyone, good day again. Let us continue our topic with resistive sensors. So for today we will be talking about just resistive sensors. So actually there are a lot, several sensor, and one of that simple sensor is the resistive sensor. So this sensor changes resistance according to the change of environment. So example of that, one of the example of that is here. This is a photo resistor, and we have a thermistor and a flex resistor. So this photoresistor changes resistance according to the brightness, and also with the thermistor, the resistance changes with respect to temperature, and with flex resistor it changes how it bends, how much it bends. So these devices bend, so the change ang iyahang resistance according to how we bend this device. So in our microcontroller, actually dili kabasa directly ang atong microcontroller with resistance. So the Arduino, for example, ang iyang mabasa is the voltage. So in order to do that, we must use a supply, and in this connection we use a voltage divider here. So it is just actually a voltage divider. Kindly review your electrical circuit 1 or 2 basic electrical circuit theory na subject. So instead na typical resistance ang atong ibutang ani, so this block here, this rectangle block, we could replace that by this resistive sensor. So accordingly, if the change ang atong resistance, the voltage measured here that is connected to our Arduino pin also changes. So with that, we can measure how bright it is, how hot it is, warm or cold, and how it bends. So that is how we connect this different resistive sensors. So with that, okay, yeah, right, as resistance changes, voltage changes, as I have mentioned earlier. Now let us dig in deeper to one of the example of resistive sensor, and that is our photoresistor. So a photoresistor here, so ganina diba katong rectangle na block, we just replace it with this device of photoresistor. So we can fix our resistance here, and here we have the pin, atong pin padung sa Arduino. So sa photoresistor, ang brightness niya ga-increase. As brightness increases, resistance decreases. So how would we measure this? For sure kabalo man mo sa computation sa, for example, unsay voltage diri, let's say V out. Okay, so let's say this one is our V out, and this one 10 kilo ohms is R2. So computing V out is this one. Let's say we have R2 over R1. Hindi ko kasulat. Okay, we have R1 plus R2. So this one, let's say this is R1. So measuring the voltage here in the Vout that is connected to our microcontroller, let's say the resistance measured in our photoresistor, as we say, nag-decrease ang brightness, so nag-increase ang atong resistance. So just substitute, so 5 times fix ang R2, 10 kilo ohms, so 10 kilo ohms, and also resistance of photoresistor 10 kilo ohms, 10 kilo ohms, so we have 5 times 10 over 10 plus 10, so we have 2.5. And as we increase the brightness, the resistance now decreases. So substituting that, we have 5 times 10 kilo ohms over 5 plus 10 kilo ohms. Then we measured a voltage that would go to our microcontroller is 3.3 volts. So that's how we measure the brightness using a photoresistor. So that is an example how the resistive sensor works. Now let us see how a voltage controlling sensors would be used in our microcontroller applications. So another type of sensor other than the resistive sensor that I have shown you a while ago, we have also a voltage controlling sensors. So ang difference lang nila is katong mga resistive sensor, ang resistance adto nga device ga change depending on how the environment also changes. For example, ang brightness ga increase o ga dim, then ga change pod ang iyang resistance. Or kung thermistor, kung ang init or ang kabugnaw niya, so ga change pod ang resistance adto on how ga change ang temperature. With that, otherwise, a voltage controlling sensor, dili resistance ang ga change niya if ga change ang iyahang environment. One of that example of voltage controlling sensor is the passive infrared motion sensor, or the PIR sensor. So this PIR sensor has 3 terminals. So this top here is connected directly to our microcontroller, same as the resistive sensor. And we have a terminal here also that is directly connected to our supply, and other terminal is connected to the ground. So this motion sensor is pulled down when motion is detected. So kung na motion, ma-connect ni siya, so murag na ay connection dire, then it pulls down here, kay murag ma-pull down siya to the ground. Otherwise, kung wala siya ma-detect na motion, this device here would float. So ang mahitabo, kung wala siya ma-detect na motion, ang mahitabo niya is kini mo ni ang Arduino na wire padong sa Arduino, then it would pull up. Kinahanglan pa na ako i-drawing. Gusto din mag-drawing sa PowerPoint. Okay. So this is 5 volts. So kining motion sensor ga-float na siya, so open. So in this, kung walay motion, then it pulls up, so high siya. So mo lang to, mo nang ginatawag ni siya nga klase nga sensor as open collector signal, since it floats without motion. So I hope it is clear. So kung wala pa to siya nasabtan, you can directly message me kung sa inyong pangutana. And Other voltage controlling sensors other than this PIR sensor are the triple axis analog accelerometer and dual analog gyroscope. So this type of sensor are used to detect the orientation of a device, and also it uses for one example of the application of that is the quadruplane, so where orientation is vital for stability. So this triple axis analog accelerometer, or just any accelerometer sensor, it reports acceleration in 3 dimension, specifically sa triple axis since 3 dimension. And for the dual axis gyroscope, it reports angular velocity in 2 dimension. It also, I would like to highlight that this type of sensor, kining mga voltage controlling sensor, I would like to emphasize that this type of sensor, ga-output ni siya og voltage. So, dili na kinahanglan og unsa pa, voltage divider and so on para ma-detect ang iyahang voltahe, no? So, I think that's it for this lesson. So, probably we will have a demo about sensor in our next topic. Thank you.